dear students. So in this class, we can revise the chapter trigonometry. So first we can revise basics of trigonometry. You know very well what is trigonometry. What is the meaning of trigonometry? So in Greek, tri means three, and gono means what? Three sides and metric. Yes, measurement. Three sides measurement is called trigonometry. Right? So trigonometry is based upon Pythagoras theorem and right angle triangle. Pythagoras theorem and right angle triangle. So what is the Pythagoras theorem? What it states? Pythagoras theorem states that in a right angle triangle, the square of hypotenuse is sum of squares of other two sides. So for example, we can take one triangle here, triangle ABC, triangle ABC, and it's right angle at B, and it's right angle at B. Imagine angle theta, theta, angle theta forming at C, and the side opposite is A. Side is called opposite because the AB side is opposite to this angle theta, opposite to this. Yes, adjacent are base. This side is adjacent are base, and this case is hypotenuse. This is hypotenuse. So meaning here we are studying six functions. The first one is sine theta, sin, sine cos, cosecant theta, cosecant theta. The next secant theta. The next cotangent theta, cotangent. So in short, you can write it as this is cos theta, tan theta, cosec theta, sec theta, and cot theta. Sin theta, cos theta, theta, cosec theta, sec theta, and cot theta. So next, some important relationships. Sin theta is reciprocal of cosec theta. Sin theta is reciprocal of cosec theta. And cos theta is reciprocal of sec theta. Cos theta is reciprocal of sec theta. And tan theta is reciprocal of cot theta. Similarly, vice versa. See, cosec theta is reciprocal of sin theta, and sec theta is reciprocal of cos theta, and cot is the tan we can express in the form of sin and cos, as well as cot also we can express in the form of sin and cos. So tan theta is equal to sin theta upon cos theta, and cot theta is equal to cos theta upon sin theta. See, there are six trigonometric functions. Sin theta, cosine, we call it as sin, cos, tan, cosec, sec, and cot. Some important relations. Sin is the reciprocal of cosec, cos is the reciprocal of sec, tan is the reciprocal of cot. Similarly, cosec is the reciprocal of sin, sec is the reciprocal of cos, and cot is the reciprocal of tan. And tan theta we can express in the form of sin and cos, that is sin theta upon cos theta. How can we express cot? Cot is nothing but cos theta upon sin theta. Okay. Then after this, we learn standard angles. Correct? Sin a function and here angle 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Here function sin, cos, and tan. In the Greek question I can take. Sin 0, sin 30, half, sin 45, 1 upon root 2, sin 60, root 3 upon 2, sin 90, 1. sign value lies between 0 and 1. When the sign angle increases, then the value also increases. Sin 0, 0, sin 30, half, sin 45, 1 upon root 2, sin 60, root 3 upon 2, sin 90, 1. Then cos 0, 1, cos 30, root 3 upon 2, cos 45, 1 upon root 2, cos 60, half, cos 90, 0. So the cos value lies between 1 and 0. Sin value 0 and 1, cos value 1 and 0. When the cos angles, the function of cos angles increases, then the values are decreases, not increases, decreases. Next tan 0, 0 upon 1, 0, 0 upon anything is 0. Tan 30, 2 to cancel, 1 upon root 3. Sin 45, 1. Sin 60, root 3, 2 to cancel, root 3. And sin 90, not defined, infinity. Correct? So similarly, cosec reciprocal of sin. Cosec 0, 1 upon 0. Cosec 30, 2. Cosec 45, root 2. Cosec 60, 2 upon root 3. Cosec 90. So similarly, sec reciprocal of cos. Similarly, cos reciprocal of tan. So any doubts here? No doubts. So after this, trigonometric identities. How many are there? Only three identities. The first one is sin square theta plus cos square theta is equal to 1. First identity. And second identity, 1 plus tan square theta is equal to sec square theta. And the third identity, 1 plus cot square theta is equal to cosec square theta. So these are the three identities. First, second, and third. So can we take some examples to prove that? Prove that. First example, prove that. You are trying to prove that. Sin A 1 plus cosec A sin A plus cosec A whole square plus cos A plus sec A whole square is equal to 7 plus tan square A, a square of tan A plus square of cot A. Do that sin A plus cosec A whole square plus cos A plus sec A whole square. Sin A plus cosec A whole square plus cos A plus sec A whole square is equal to 7 plus tan square A plus cot square A. Simple example. First, we can take LHS left hand side. LHS sin A plus cosec A whole square plus cos A plus sec A whole square. LHS side. Okay. So the first sin A plus cosec A is in the form of A plus B whole square, and even cos A plus sec A is also in the form of A plus B whole square. So you can expand this A plus B whole square. Expansion of A plus B whole square, A square plus B square plus 2AB. So A is sin A, square of sin square A plus cosec square A plus 2 times of sin A into cosec A. Similarly, cos A plus sec A is in the form of a plus b whole square, cos square a plus sec square a plus 2 times of cos a into sec a. Okay. But the answer is in the form of tan and cot. Sin square a plus cos square a is nothing but 1 because of identity. Sin square theta plus cos square theta is 1 plus cosec square a. We can write in the form of cot. You know the identity. 1 plus tan square a. 1 plus cot square a. Cosec square a. 1 plus, yes, 1 plus cot square a is equal to cosec square a. Here 2 sin a into cosec is 1 upon sin a plus cos square already written, sin square plus cos square, sec square 1 plus tan square a, 1 plus tan square a plus 2 cos a into sec is again 1 upon cos a. Cos a cancel, sin a cancel. So you can add the numbers, numericals 1 plus 1 2, 2 plus 2 4, 4 plus 1 5, 5 plus 2 7. 7 plus remaining term tan square a plus cot square a. Tan square a plus cot square a. So this is your RHS. Okay. Yes, next example you can take. Prove that. Prove that. Prove that. Under root 1 minus cos a. Under root 1 minus cos a divided by 1 plus cos a. Under root 1 minus cos a divided by 1 plus cos a plus under root 1 plus cos a, 1 plus cos a divided by 1 minus cos a, 1 minus cos a is equal to 2 times of cosec a, 2 times of cosec a. Try this one. Under root 1 minus cos a divided by 1 plus cos a, under root 1 minus cos a divided by 1 plus cos a plus under root 1 plus cos a divided by 1 minus cos a is equal to 2 times of cosec a. Yes. Did you get the answer? Yes, sir. LHS we can take first. LHS side. Under root 1 minus cos a divided by 1 plus cos a plus under root 1 plus cos a divided by 1 minus cos a is LHS side. Okay. So here what to do? These are the under roots 1 minus cos a, 1 plus cos a. Functions are under roots. So first rationalize the denominator. Rationalize the denominator. So denominator is 1 plus cos a. Rationalizing factor is 1 minus cos A. 1 minus cos A divided by 1 plus cos A. Rationalize the denominator. So the rationalizing factor 1 minus cos A divided by 1 minus cos A. So similarly, for next term also you can do the same. 1 plus cos A divided by 1 minus cos A. So here also you can rationalize the denominator. So the rationalizing factor is 1 plus cos A divided by 1 plus cos A. So these are all under roots. Functions are under roots. Okay. See, the numerator can see 1 minus cos A into 1 minus cos A. 1 minus cos A whole square. So it's under root 1 minus cos A whole square. So divided by, here the denominators are two. One is 1 plus cos A and another one is 1 minus cos A. And it seems like A plus B into A minus B. You know the identity. A square minus B square is equal to A plus B into A minus B. So here A is 1 and B is cos A. So we can write this A plus B into A minus B as A square minus B square. So then we can write here 1 square is 1 minus cos square A plus under root, again under root 1 plus cos A into 1 plus cos A, 1 plus cos A whole square. Same terms. 1 plus cos A whole square divided by same. It's also in the form of A plus B into A minus B. A plus B into A minus B is A square minus B square. So A square is 1 and B square is cos square A. Am I right? Yes, now one more time we have to write same as it is. 1 minus cos A whole square divided by 1 minus cos square A. First identity. Sin square theta plus cos square theta is equal to 1. And sin square theta is equal to 1 minus cos square. So 1 minus cos square is nothing but sin square. Plus similarly 1 plus cos A whole square divided by 1 minus cos square is nothing but again it is sin square. Am I right? Yes. Now what to do? Under root 1 plus cos A divided by sin A whole square. 1 plus cos A divided by sin A whole square. Both the numerator and denominator together square. Plus under root same 1 plus cos A, it's minus 1 plus cos A divided by sin A, so together square, numerator and denominator together square. So square root get cancelled, so remaining terms 1 minus cos A divided by sin A plus 1 plus cos A divided by sin A. Am I right? So the LCM is sin A. LCM is sin A. 1 minus cos A into 1 plus cos A. 1 minus cos square. 1 minus cos square. 1 minus cos square is nothing but yes. Sorry, addition is the right. Okay. So 1 minus cos A, 1 minus cos A plus 1 plus cos A. So plus cos A minus cos A cancel is equal to 2 upon sin A. 1 upon sin is nothing but cosec. 2 into cosec. So this is your RHS. 2 into cosec. Okay. This is the next question. Those who have solved this one, note down next question. Third one. Do that 1 upon sec A minus 1. 1 upon sec A minus 1 plus 1 upon sec A plus 1. 1 upon sec A plus 1 is equal to 2 times of cosec A, 2 times of cosec A into cot A. 1 upon sec A minus 1 plus 1 upon sec A plus 1 is equal to 2 upon cosec A into 40. And this question is appeared in 2024. Model question paper number 2. 2024 model question paper number 2 question 1 upon sec A minus 1 plus 1 upon sec A plus 1 is equal to 2 times of cosec A into 40. So first we can take LHS and 2 RHS. Is finished. Take sec A as a cos. Huh? No. Directly you solve, right? In this sec you took. First LCM you took, I think. See, LHS we can take first here. LHS side 1 upon sec A minus 1 plus 1 upon sec A plus 1. See, two methods we have. The first method, directly we can take LCM of sec A minus 1 and sec A plus 1. Instead of that, if you convert sec as a cos, in that way also we will get the answer. Correct? So first what we do, this 1 is in numerator, 1 write as it is, and sec A minus 1 is in denominator. Sec I will write it as 1 upon cos. 1 upon cos A minus 1. Similarly, second term, sec A, this sec also I can write in the form of cos. 1 upon cos A plus 1. So the denominators are cos and 1 cos and 1. Numerator 1 write as it is, and in denominator the LCM is cos. LCM is cos. Here already cos is there, but here cos is not there, so we need to multiply with cos. 1 minus cos A plus 1 whole divided by, again the LCM is cos A. 1 into 1, 1, cos A plus 1, cos A. So the rule is A divided by B whole divided by C upon D. Here this C multiplies to A and this C multiplies to B. Means AD divided by BC. Here 1 upon 1, similarly 1 upon 1, this cos A multiplies to numerator, that is cos A divided by this 1 multiplied to 1 minus cos A, 1 minus cos A plus similarly cos A divided by 1 plus cos A. See the LCM now. Cos A is numerator and 1 upon 1 minus cos A is in denominator. Similarly, cos A is in numerator, 1 plus cos A is in denominator. So the LCM 1 minus cos A into 1 plus cos A. LCM 1 minus cos A into 1 plus cos A. Am I right? It's now cos A into 1 plus cos A, 1 plus cos A plus cos A into 1 minus cos A. Okay. So instead of multiplying, do not multiply here. Cos A is common. Take it outside. Cos A outside. So remaining terms inside the bracket 1 plus cos A plus 1 minus cos A bracket complete divided by. So this is in the form of A plus B into A minus B. A plus B into A minus B is nothing but A square minus B square. A is 1 and B is cos square, correct? So 1 minus cos square A. So here plus cos A minus cos A can cancel. 1 plus 1, 2. 2 times of cos A divided by 1 minus cos square A is nothing but sin square. According to the first identity, sin square theta plus cos square theta is equal to 1. And 1 minus cos square theta is sin square. So sin square A. 2 cos upon sin cot. Cot A. 1 upon sin cosec. So this is your RHS. See. 2 cosec into cot. How many have you solved? Only 4 to 5. 1, 2, 3, 4, 5. Yes. Remaining note down. Those who are solved this one, so can note on the next example. Prove that. Prove that. 1 plus sec A divided by sec A divided by sec A is equal to sin square A upon 1 minus cos A. 1 minus cos A. Model question paper number 3. This question appeared in third model question paper in the year 2024. You can take LHS separately and RHS separately. Just simply write. That is the one bit. And the other way, take LHS and RHS separately. First LHS we can take. LHS, left hand side. So here 1 plus sec A divided by sec A. LHS side, correct? So 1 sec A I can write it as a cos A. Reciprocal of sec is cos. Similarly, sec A is 1 upon cos A. So now we have to take LCM. In numerator, denominator, LCM is cos A. So cos A 1 of cos A plus 1 whole divided by 1 upon cos A. Cos A cancel. So the remaining term cos A plus 1. Okay. After this is complementary. So the last step is cos A plus 1. Similarly, we can take the RHS side. So we have sin square here, the numerator sin square divided by 1 minus cos. Identity 0. Identity sin square theta plus cos square theta is equal to 1. So similarly, 1 minus cos square is equal to sin square. So sin square I can take it as 1 minus square of cos A divided by 1 minus cos A. So it's in the form of A square minus B square. A square minus B square. Expansion of A square minus B square. A plus B into A minus B. 1 plus cos A is from equation 2. LHS is equal to RHS. Hence proved. Okay. Is there any doubts here? Yes. Next, one more example we can take. value of find the value of find the value of 5 times cos square 60 degree plus 4 times sec square 30 degree minus tan square 45 degree cos square 60 degree plus 4 tan square 45 degree divided by sin square 30 degree plus cos square 30 degree. The solution is here. 5 times cos square 60 degree. What is the value of cos 60? Sin 30 is nothing but what? Cos 60. Sin 30 is cos 60 is also 1 upon 2 square plus 4 times 30 is root 3 upon 2. Sin 60 is also root 3 upon 2. Correct. So cos 30 is root 3 upon 2. Then sin 30 2 upon root 3. Reciprocal 2 upon 2 upon root 3 whole square minus tan square 45 1. Correct. 1 square divided by divided by sin square theta plus cos square theta 1. No need to write the values because we have identity sin square theta plus cos square theta is equal to 1. 5 divided by root 3 square square root cancel 3 minus 1 divided by 1. LCM is 12. 4 3 1. 4 3 is 12. 4 how much are 12? Please. 3 how much are 4 are 1 how much are 12. 1 12. Am I right? Yes. Now 5 3 is 50. 4 4 are 16 4 are 64. 1 are 6. Sorry, 4 minus 2, 2. 6 minus 1, 5. 5 plus 2, 7. 5 plus 1, 67 upon. Correct? Yes, how many people got this? It's not bad. It's down. Okay, can we take next example? Okay, next example. 2024. Question paper number 4. Prove that. Prove that. Prove that. Under root 1 plus sin theta. 1 plus sin theta divided by 1 minus sin theta. 1 minus sin theta plus under root 1 plus sin theta. 1 plus sin theta is equal to 2 times of sec theta. Prove that. Under root 1 plus sin theta. Prove that under 1 plus sin theta divided by 1 minus sin theta plus under root 1 minus sin theta divided by 1 plus sin theta is equal to 2 times of rationalize the denominator. 2 times you have to take the rationalizing factor. 2 times. First time is 1 plus sin theta. Second time yes, solved. Okay. So simple example. See, so we can take LHS side first. LHS left hand side. Under root 1 plus sin theta. And here, now rationalize the denominator. 1 plus 2. 1 plus sin theta. Rationalizing factor is 1 plus sin theta divided by 1 plus sin theta. Plus same under root 1 minus sin theta divided by 1 plus sin theta. So the rationalizing factor 1 minus sin theta divided by 1 minus sin theta. So now we have to multiply. Under root 1 plus sin theta into 1 plus sin theta. 1 plus sin theta whole square. Under root 1 plus sin theta whole square divided by here. This is in the form of a plus b into a minus b. So directly I can write it as a square minus b square. 1 square is 1 minus sin square theta plus. So here the numerators are 1 minus sin theta into 1 minus sin theta. 1 minus sin theta whole square divided by 1 plus sin theta into 1 minus sin theta. 1 square minus again it is sin square theta. Correct? So now under root 1 minus sin square theta is nothing but cos square. According to the identity, sin square theta plus cos square theta is equal to cos square theta. Plus again it is cos square theta. Okay. So now under root 1 plus sin theta under root 1 minus sin theta divided by cos theta whole square. Square root get cancelled, square root get cancelled. So the remaining comes 1 plus sin theta divided by cos theta plus 1 minus sin theta divided by cos theta. So the LCM is cos theta plus sin theta minus sin theta get cancelled. 1 plus 1, 2, 2 upon cos is nothing but 2 sin. Correct? Next example you can take. So that root 3 plus 1. So that root 3 plus 1 into 3 minus cot 30 degree. 3 minus cot 30 degree. Tan cube 60 degree. Minus 2 times of sin 60 degree. 2 times of sin 60 degree. Prove that root 3 plus 1 minus cot 30 degree is equal to tan cube 60 degree minus tan cube 60 degree minus 2 times of sin 60 degree. Root 3 plus 1 into bracket 3 minus cot 30 degree. Root 3 into bracket 3 minus cot 30 degree into bracket 3 minus cot 30 degree. Am I right? Root 3 right as it is 3 minus what is the value of tan 30? Tan 30 is 1 upon root 3. Cot 30 root 3, correct? So cot 30 is root 3. And this one as it is plus 3 minus cot 30 is root 3. Am I right? 1 into anything is same number will get. Root 3 into 3, 3 root 3 minus root 3 into root 3, 3 plus 3 minus root 3 plus 3 minus 3 cancel. 3 root 3 minus root 3, 3 root 3 minus root 3. What is the value of tan 60? Root 3, correct? So root 3 cube is nothing but what? Cube of root 3 is equal to 3 root 3, am I right? Cube of root 3 is root 3 into root 3 into root 3. 2 root 3 is nothing but 3 and 1 root 3 as it is 3 root 3. root 3? 3 root 3 is nothing but root 3 cube. So root 3 cube is nothing but tan 60. Correct? Tan cube 60. So tan cube 60 degree minus. What is the value of sin 60? Root 3 upon 2, correct? So sin 60 degrees root 3 upon 2. What is root 3? Root 3 is nothing but 2 times of sin 60 degrees. This 2 we can take left hand side. Minus 2 times of sin 60 degree is nothing but 2. Tan cube 60 minus 2 times of sin 60 degree is nothing but 2. So next example you can take. Next example. Prove that. Set A. 1 minus sin set A plus tan A. Set A plus tan A is equal to A plus tan A is equal to under root 1 plus cos A into 1 minus cos A into cosec A into cosec A. Solve this one. Sec A into 1 minus sin A into bracket sec A plus tan A is equal to under root 1 plus cos A into 1 minus cos A is equal to cosec A. See, don't get confused here. One thing I will tell you. Look at this question. LHS side. LHS under root of 1 plus cos A into 1 minus cos A into. Am I right? Just we have to reduce this, right? RHS. We have to write the simplified form of this RHS side. See, under root A square minus B square. Under root 1 square minus cos square A into cosec A. Simplified form we can write this. So 1 minus cos square A is nothing but according to sin square A. So under root sin square A, right? Into cosec into cosec. Square root sin A into cosec is nothing but 1 upon sin. Sin and sin A cancel 1. It means that you have to do that 1 minus sin A into sec A plus sin A is equal to 1 you can. Hope you can understand this. Yes, please note down. So, yes. This one you have. One minus sin A, and second you can write it as 1 upon cos A and tan is sin upon cos A. So 1 minus sin A into 1 plus sin A is nothing but 1 square minus sin square A. 1 square minus sin square is cos square. Correct? So cos square divided by cos square you can cancel. Yes, sir. The next example. 26 questions are there. Now we are at 9th question. Then I can complete today. Remaining can I will solve tomorrow. Okay? Because tomorrow English exam is waiting for the next examination. So that's what I have to take next 2 questions. 2025 question paper number 1. Prove that sin theta divided by 1 minus cos theta divided by 1 minus cos theta plus tan theta divided by 1 plus cos theta 1 plus cos theta is equal to cot theta plus sec theta into cosec theta is equal to cot theta plus sec theta, cot theta plus sec theta into cosec theta into cosec theta, sin theta upon 1 minus cos theta plus tan theta upon 1 minus cos theta is equal to cot theta plus sec theta into cosec theta. Prove this one. So take let's the same. Take the lesser side. So then you can write in the form of sin and cos. Sin theta upon 1 minus cos theta. Set as it is. That time you can write in the form of sin and cos. Sin theta upon cos theta will divided by 1 plus cos theta. So take the LCM. Yes, sir. Did anyone get the answer? Yes, anybody? LHS, we can take LHS side. LHS is sin theta. 1 minus cos or what it is? 1 minus cos theta. 1 minus cos theta plus tan theta divided by 1 plus cos theta. Yes, anybody get the answer? No one. You hopeless. Huh? Okay. So now can take LCM directly first. 1 minus cos theta into 1 plus cos theta. So sin theta into 1 plus cos theta plus tan theta into 1 minus cos theta. Okay. So now sin theta as it is into bracket 1 plus cos theta. This also you can write as 1 plus cos theta plus tan theta is there. Tan I can write it as sin theta upon cos theta. Tan into bracket 1 minus cos theta. 1 minus cos theta. So divided by 1 minus cos theta into 1 plus cos theta. 1 minus cos square. 1 minus cos square is nothing but sin square. So directly I can take sin square theta. Sin square theta. Am I right? Yes. See, in the numerator, denominator cos theta is there, and here 1 is there. In first term, denominator is 1. In second term, denominator is cos theta. So we need to take the LCM. LCM is cos theta. Sin theta into bracket 1 plus cos theta. So this multiply with the sin theta, so it becomes sin square theta. Sin theta into sin, sorry, cos theta, sorry. Sin theta into cos theta. Sin theta into cos theta into bracket 1 plus cos theta plus sin theta into bracket 1 minus cos theta divided by whole divided by cos theta divided by sin square theta. Sin square theta divided by 1. Okay. This 1 multiply with numerator and this sin square theta multiply with denominator. So now sin theta is common, take it outside, into bracket cos theta into bracket 1 plus cos theta plus 1 minus cos theta. 1 minus cos theta. That is complete. Am I right? Whole divided by cos theta into sin square theta. Cos theta into sin square theta. 1 sin theta, 1 sin theta, cancel. Cos theta into 1 cos theta plus cos into cos square theta plus 1 minus cos theta divided by cos theta into sin theta plus cos minus cos get cancelled. But the answer is cot theta plus sec theta into cosec theta. So cos square theta plus 1 divided by cos theta into sin theta, remaining term. Okay. So here what I will do, separate the terms. Cos square theta divided by cos theta into sin theta plus 1 divided by cos theta into sin theta. Cos square, cos get cancelled. Cos upon sin is cot theta plus 1 upon cos sec, 1 upon sin cosec. So this is your RHS. Cot theta plus sec theta into cosec theta. Note on first. Last one example homework you can take. Note on this. So last 10th example. How many have solved this question? Nobody, right? Only one. Note on first. In one question you can take it as a homework. Question number 10, model question paper number 2, 2025. Do that. Cosec A minus sin A. Cosec A minus sin A into tan A plus cot A. Tan A plus cot A is equal to cot A into cosec A. Cot A into cosec A. Model question paper number 2, 2025. Cosec A minus sin A into tan A plus cot A is equal to cot A plus cosec A.